What's up, everybody? I'm Matt Gary, and on this 8th episode of the Separation of Concerns and Apex Common tutorial series that I'm putting together, we're going to go over how to implement a service layer using the Apex Common library. Alright guys, so welcome to episode 8 of this Separation of Concerns and Apex Common tutorial series that I'm putting together to hopefully help everyone out there figure out how to use this and make it a little easier for people to start adapting in their own orgs, because this is really important stuff and will make your org really easy to deal with in the future, really extensible, adaptable to change, all that kind of stuff. So in this episode, we're going to go over how to implement a service layer class that works well with the Apex Common library. And I'm going to start this a little different than the normal ones, where I tell you why you want to do this, blah, blah, blah. I'll get to that. But one thing I want to point out is that the Apex Common framework, and really any other framework in existence, doesn't set a groundwork for you for a service class. There's nothing to, there's no class to extend, there's no methods that you like pull from or whatever. There's no groundwork here. And the reason that there's no groundwork is because service layer classes are business logic, right? And every business's logic is different. So every org's logic will be different. There will not be similar methods that you can just, grab from another class, at least that a library could provide you, right? So there's no base layer here, but there is in the fflib application class, which we go over in episode 4 of this series. If you haven't looked at it, you should probably check it out, because it is extremely important for the rest of the series that you understand how this particular thing works. In the fflib application class, there is a ServiceFactory class, and basically what it does is give you an idea and really a setup that's great for managed packages if you're doing managed packages, but it gives you an idea of how to dynamically initialize or instantiate service classes using the factory pattern. So we're going to figure out how you set up those classes to work with the factory pattern or the service factory that's been set up for Apex Common. Now, as far as why you would want to set things up this way, this is going to let me see how I can phrase this. In lots of orgs, eventually what happens is you start to grow. You grow and you grow and you grow. You have one successful implementation, and then other business groups start to see, oh, this is cool, I should join too. And another business group says, oh yeah, this is awesome, I like the way that these two are doing it, I should join too. And then what happens is, if you don't build your code in a nice dynamic, in some kind of dynamic way, you're going to get classes that just become out of control, right? You might have a B2C accounts, and you might have B2B accounts, and you might have, marketing accounts, whatever else. That you could have tons of different account types in the system for your different business groups, and they could all need different logic based on the record type for the account or whatever else. So what happens is, if you don't have a way to figure out how to break out that logic into separate classes that you can kind of like dynamically determine which to run at runtime, you get these huge classes. Either that, or you get these huge if-else statements eventually in all of your methods. And we really don't want that, because it becomes harder and harder to maintain over time, especially if you're working for a larger business and, you know, your Salesforce instance really takes off. So as far as why this is great, it really helps you separate out your concerns and make your code really nice and neat and organized. It also makes it so that you can call your service class from, you know, an Apex controller or a batch class or whatever else, and it's never going to know the difference. Like, you're not going to have to do anything special, I guess, to or change that call out because you've added new logic for group A, B, or C or something. So enough talking about this, I guess. Let's build this together and figure out how this, you know, factory pattern setup for your service classes actually works. Okay guys, so today what we're going to be building to kind of figure out how this whole service layer factory implementation works is a way to allow us to call a different service implementation class based on the record type of a case. So basically what I've done is, you know, set up several case record types for my cases. So I've got a B2B sales case, a B2C service case. I actually think I've changed this since then. Yeah, B2C sales case and a marketing sales case. And basically these record types, for our purposes, represent the different business groups that are involved in our help desk, right? So for this, imagine that we have a help desk. That help desk has 3 different teams, and their processes are all pretty different, right? And ideally, we don't want to merge all their code, their implementation code, into the same place. Theoretically, they all use entitlements, and we're going to figure out a way to call a help desk service implementation that is unique for each of these at runtime based on a case record's record type ID. Okay? It's going to be pretty cool, so stick with me. I promise it's a little complicated, but I'm going to go over every single step, and hopefully it'll be less complicated. So the first thing that we are going to do is find our ServiceFactory in the fflib application class. Now, if you've not watched episode 4 of this tutorial series, you really should. It goes over the fflib application class in depth, and it is pretty critical you understand this class to some extent before you go too deep into this series, at least with the Apex Common tutorials that I'm going to do. So right now, the only thing that this ServiceFactory can map on is basically a class type to a class type. Generalizing a bit, but that's basically what we're doing here. We're saying, I want to map this from class type A to class type B. And this is actually a great a pretty useful setup, I guess I should say, if you are a managed package provider. So I'm not going to go over that because I think 90+% of the people that I'm talking to right now are not managed package providers, but just know that this can come in a lot of handy, especially if you want your customers to be able to implement their own code, dynamically. It can be pretty cool what you can do with this. So anyway, on to what we were supposed to be talking about before I got off on a little side note there. The first thing that we're going to do is create a couple new maps. Now, you could extend this class and do some other fancy stuff, but I'm trying to keep this a little simpler for this video. So we're going to create a new map that maps by string to type, and this is going to be our basically our services by record type map. Right? So basically what I'm saying is we are going to get a let's make this even more. Service class by record type. So we're going to get a service class returned to us, right, by the record type that we pass in here. And the other thing that I'm going to go on ahead and do, although we don't necessarily, you know what, I'm just going to skip it. You would want to set up, if we're going to do mocking, you'd want to set up a mock for this too. I guess it won't take me much time, so we can go on ahead and do that. It would be mock service class by record type. Okay. And we will create a new constructor to set this up. So we'll say public ServiceFactory. Again, this is a new constructor for our inner class ServiceFactory right here. And it's going to take a map of string by class type, and we'll call this service class by record type, and then we'll say this dot service class dot record type equals service class dot record type, and we will initialize our mock service class record type. That should be mapped though. Okay, so what have we done here? Basically, we are giving ourselves a way to initialize this ServiceFactory with a map of a string that represents our record type to a class, a service class implementation class. And that's really it. So the next thing we'll need to do is create another new instance method. So these new instance methods that come by default, they're not going to, well, really cut it for us here. Let me do this after the constructor. So what we'll do is we'll create a new new instance method, and we'll call this new instance by record type to make this, you know, very straightforward. And we'll pass in the record type to it. Now, the first thing we'll want to do is figure out if we have got a mock instance for mocking in the future. Service class dot record type dot contains key record type, and we'll return that mock instance, right? So basically what we're saying is, okay, if we've set a mock for this, then we'll return it. This is less important to the conversation, but it is important, you know, if you're going to use mocking to set something up like this. And I'm not going to go over it, but you would also need to set up a set mock method for it, right, where you put stuff into the map that we're setting up here. So let's not try to focus too much on the mock part. The next thing that we'll do is we'll say type service impl equals services or service class by record type dot get the record type, and then we'll say something like if service impl equals null, then we'll throw a developer exception. And I'll explain that in a second. And if it's not, then we'll go on ahead and return our service impl, if I can spell. And that's pretty much it. So basically what we're doing here is we're figuring out, all right, are we in a test, right? Do we need to return a mock class? Again, don't dwell on this too much. We'll go over this in episodes 15 through 17 of this series. And then what we're doing is we're saying, all right, let's check to see if our record type exists in our map. And if we do indeed get something back from our map, or sorry, if we don't get something back from our map, throw a exception that says no implementation is registered for the record type, so that we know that there's something wrong with the application class that we've set up, which we'll build here in a sec. And then, if everything goes well and we pass through this if statement unharmed here, then we'll return a new instance of our service method, or our service class that we care about. Okay, so we've set that up. We've set up our new, setup for the fflib application ServiceFactory. The next thing that we need to do is create an application class. So we're going to go ahead and do that together real quick, super simple. I'm not going to make it overly complicated. We'll say service desk application. Yep. And basically what we're going to set up is a way to get our service classes. So we'll say public static final fflib application dot what am I doing? ServiceFactory, and we'll call it service equals new fflib application ServiceFactory. And then we'll need to do the following. We'll create a new map of string to type and set up our mappings for that. And I've got these over here, so I'm just going to copy them over so I don't have to type all this out. But basically, you are going to put in the names of your record type, right? And then what classes they equate to. And we're going to create these, create new versions of these classes here in a sec. But just so you know how this works, you're going to pass in that map of record type and class type, record type to class type into your ServiceFactory, which will then, run this constructor that we just made and set up our map that we care about, right? So back here in this, I've created these things already, but we should create them together so that you understand what these are, right? What these help desk B2B service impl class, blah, 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 whatever. But before, well, let's just create them together first. So, like I said before, we're assuming that the B2B team kind of has their own separate processes for things. B2C kind of has their own separate processes, and this service desk application that we've built in our Salesforce org. And basically what we need to do is figure out a way to dynamically call the right code based on the case at runtime. So we need different classes for each of these, business units, basically. So let's go ahead and create them. I'm going to name them a bit different, and then I'm going to come back here and update them. So we're going to create a class, and we'll call this service desk B2B service impl. Cool. And we'll just copy this name and create a few more. So we'll say service desk B to C service impl. And impl stands for implementation, but implementation is kind of a long word, and so it often gets abbreviated to impl. And then we'll have a marketing service implementation class. Now, I think I briefly stated this earlier, but let's pretend that every single one of these service desk implementations, or, let's pretend that our B2B service desk, our B2C service desk, and our marketing service desk all use entitlements or case milestones, whatever. So they all need to have some code that, I don't know, maybe starts the milestone process and stops, or starts the entitlement process and stops the entitlement process in different scenarios. But every single one of these groups have different, completely, unique implementations for this. So how do we handle this? Here's what we can do. We know that they all need a similar method, right? They all need this similar start milestone, stop milestone method. Every single one of them is going to have this done. So what we can do to make our code even more abstract here and use the factory pattern really well is create an interface. And we'll call this, got some bad allergies, I guess. We'll call this service desk interface. So this is a generic interface that we can use across all these implementation classes. And, once I press enter 30 times, we'll change this to an interface, and we'll give it a couple methods. We'll say maybe that we want a list of cases returned to us or something, and we'll call this start entitlement process, and maybe pass it a case CS. Now I know normally you're supposed to, what am I doing here? Bulkify these, but bear with me, it'll be bulkified but in a different manner. And then we'll have another one called stop entitlement. Okay, I'm good so far. Stop entitlement process, and we'll pass it a case. Okay, cool. So we've got this interface. Now, if you're not super familiar with what interfaces are, don't, I guess, freak out too much. Basically, all they are a contract between this interface and the class that implements it that says, hey class, you've got to implement these methods. And at a base level, that might not seem great. Like, who cares? But if you have 15 different classes that implement these methods in different ways, what you can do is kind of declare them in this abstract way. You can say service desk interface equals whatever class implements it, and then because it's of type service desk interface, you can call these processes. But let me show you it in just a second. You'll see how incredibly useful this is. You can do the same kind of thing with virtual classes too, but I'm trying not to get overly complicated because this is a challenging concept. Okay, so we've created our service desk interface. We've created our implementation, our 3 implementation classes. So now the next thing we need to do is say implements service desk interface, right? And I'm going to grab these method declarations and make this a little easier because for some reason IntelliJ has been a little weird on me recently and not auto-completed these methods like it normally does. And so now we're going to implement these 2 methods that we have in our service desk interface. Now, if I had tried to create this class and save it without these methods in place, it'll actually tell me you can't. It'll say, nope, you implemented this interface. You have got to implement these methods, right? And I'm going to make this super easy because I don't want to go over the whole setting up entitlement processes, blah, blah, blah. That's not really the point of this tutorial, so I'm just going to keep this simple and make system debugs that say I called the B2B start entitlement process, and then I'm going to add the record type name. And then I'm just going to return an empty list of cases. Should have just made this a little easier on myself. Not had to return anything, but it is what it is. And we'll do the same thing here and change this to the stop process. And basically what I'm going to do is just implement these in all the other classes and update the debugs so that we can see when we set this up in just a second how this works, and that it does indeed call the different classes based on the record type that we pass to it. So let's say service desk interface, and we'll say this one called the B2C implementation. And last but not least, we're going to set up the same thing for the marketing one and slap this bad boy in here. Getting too cheeky with you guys, maybe. Okay, cool. So we've set up all these different implementation classes. I am going to try to save things now. It's going to freak out because it's going to try to save everything at the same time and probably just break. Wow, it actually succeeded. It normally doesn't. It normally freaks out and says, you got to save the interface first and then everything else. I'm actually not even sure I'm willing to believe that it did that. But I'm just gonna save it all. Let's see how it goes. Service desk application. And last but not least, this one. Okay, so we've got all these implementation classes. Cool. But right now, if I was a controller, if I was building an Apex controller, I would still kind of have to, well, let's just figure out a way to call this with no notion of the implementation specific class. It's kind of confusing maybe, but bear with me. We're going to create basically a middleman class to further abstract this so that a calling class never has to care or think about the implementation class ever. So let's go over this, and I will put my phone on silent for a second so it stops buzzing. And let's create our let's create our middleman class. I guess that's what I like to call it because that's kind of what I think of it as. We're just going to call this the service desk service. Yeah, whatever. Happens to be a service desk that has a service class. It is what it is. Okay. All right. So what should we do from here? All right. So basically what we're going to end up doing is the first method that we're going to create in here is a private static service desk interface returning service method. And it's going to take a string of record type. And what it's going to end up doing is returning a service desk interface. Service, what do we call it? Desk application service new instance by record type, and pass in the record type. I'm going to explain this, but give me a second to write one of the methods first, because it'll make a little more sense in context. So the next thing that we're going to do is basically implement both of these methods. So let me find the interface to make this a little easier. Now you notice we're not actually implementing these methods, or implementing the interface in this one. You don't want to here. And again, I will explain this a bit after we set it up together. Okay, so we actually want these instead to take a list of cases instead of individual cases, so that we can kind of bulkify this implementation here. And I'm just going to grab this code and we'll talk through it. Actually, I'll just write it. It's fine. It's not a lot of code. So we'll say list case list equals new list of cases. And what we'll do is loop through our cases that we just added in here, or sent into our method up here. We'll loop through these, and I'm definitely not typing all this out again. So basically, we will, using the schema class, grab our record type's name. So if you've never used this, pretty handy. You can just figure out your record type ID's name. I mean, I guess you technically don't even need to do that here, now that I'm thinking about it. Let's simplify this down even more. Case list dot add all service case, or CS dot record type dot name, and call the stop entitlement process class and pass it this case. All right, and last but not least, we'll do return case list. Okay, cool. All right, so what is going on here? Let's break it down. Basically, we're sending in a list of cases. We've got to figure out on a case-by-case basis what record type we're dealing with, right? So that we can initialize the right service implementation class based on the current case's record type, right? So here we go. Here's where it all comes together. So let's break this down. I'm going to go ahead and just copy this up here to make this a little easier. This is just going to call the start entitlement process. Okay, so let's break this down piece by piece, because this is where all the stuff that we built merges itself together in this, what I call middleman class. So this middleman class that your controllers or your batch classes or whatever else is actually calling is, number one, bulkified, and number two, it has no context to the individual implementations, right? It doesn't the calling class doesn't know that I'm calling the marketing service implementation or B2C service implementation or anything like that. So you've separated all of that out now, right? So you've abstracted it all even more to the point where your calling classes, they're never going to change. They're just going to call this service middleman that is going to figure things out for it and call the right code at runtime for it. Now here's where the magic, in my opinion, kind of starts to happen. We've got this service method here that returns us a type service desk interface, which, if you remember, is the interface that we implemented in all of these impl classes, right? Important stuff. And it's going to call our service desk application and grab the service variable that we set up, and it's going to call in the fflib application class that new instance by record type method that we set up, right? So if we hit Control B, this is going to take us to the method that we set up right at the beginning of this that says, all right, based on the record type you passed me, let's create a new instance or return a new instance of whatever implementation class. And so up here, what we're doing is we're saying, hey service method, I want to pass you this record type and have a service desk interface class returned to me, or a class that implements the service desk interface returned to me. And because I know, due to the contract of the interface, that the stop entitlement process method exists on it, I can call the stop entitlement process method, right? So every class that implements that interface is going to be forced to implement these methods. So the code is smart enough to know, hey, you're of type service desk interface, cool, you can call stop entitlement process. And now what happens is, when you put it all together, what we're going to end up seeing is, by calling this service method and passing the record type name, we are going to call the service, or we're going to grab the service desk application's service variable, and because that service variable is of type fflib application, we can call the new instance by record type, and when we pass in that record type, the map that we set up here, right, is going to return to us, based on our record type name, the help desk B2B service implementation class, or the B2C implementation class if we're that record type, marketing, whatever, right? Pretty cool stuff. So let's save this, and I think I've got some code, although it calls a different class. Yep, okay. Still got it over here. And we need to call instead the service desk service underscore desk service dot start entitlement process and the stop entitlement process. And we're just gonna run this and see what happens. Hopefully it works, but I could have screwed something up. We went pretty quick. Looks like I screwed something up. So let's go see what it is. Right, maybe. We never went back to the application and updated this. That's important. So let's update this to the implementation classes that we actually ended up doing. B2B service desk impl service desk B2C and service desk marketing impl. Yep. And we'll give it another go and see if it works, maybe, if I'm lucky. Nope, nope, nope. Which one is this? All right, so I figured out what the problem was. It was pretty easy to resolve. Honestly, probably shouldn't even cut this, but whatever, it is what it is. Basically, I couldn't get the record type name directly from the case. Even if I inserted it and requeried for it, for some reason, it just won't give it to me. So I suppose there's a reason that I made this to begin with. But it's been a while since I made it, and I guess I forgot about it. So anyway, now that we are grabbing the record type name via the schema object using the record type ID on the case, problem solved. No issue anymore. So that's the only thing I've changed. You can see in these two methods, instead of going case.recordtype.name, I'm now grabbing the actual record type name using the schema class. And that's it. So that's the only code change I've made. Let's go on ahead and see if this Apex Anonymous code will run and do what we think it will do, which is call a different implementation class based on the record type that we're passing it in at that moment in time. So let's check it out. And it does look to have done that, which is great, thankfully. So as you can see over here in the Apex Anonymous window, I'm creating a B2B case, then a B2C case, then a marketing case. And over here, you can see that we are looking and seeing, all right, the current record type is case sales process, and it did successfully call the B2B start entitlement process. And same thing going on here. We passed in a B2C sales case. It started the B2C entitlement process, marketing case, marketing process, B2B, and then we also call the stop process down here. And so then the next thing you see is B2B sales stop entitlement process, stop B2C one, stop marketing one. So great. Dynamically, at runtime, based on our record type, we generated the right class to call the method on, which is just, in my opinion, an incredible thing. It's like one of the coolest things that you can implement in code. I mean, there's a lot of, I love to code, so there's a lot of really amazing things that you can do. The further you kind of dive into software development in general, but this is just pretty awesome, right? And what it does is it really helps you modularize out everything. You don't, have to shove everything in one giant class for all of these different business units. You can really, separate out your methods or your logic really well for each business unit implementation, right? And then on top of that, your calling classes they'll never even have to know anything about these implementation classes, potentially. So there's just an enormous amount of flexibility in here, as I think you can see if you've followed along through this whole thing. And, it's going to make, even though this is hard to learn and get used to, it's going to make your life easier if you implement this and your org grows and grows and grows and grows. Because if you don't do something like this, you're going to just start smashing logic together until it's huge and has a bunch of spanning if statements that just confuse everyone eventually. So, yeah, I mean, I don't know. That's all I've got to say about it, I suppose. It's very powerful, as you can see. You can really start separating out your services in really meaningful ways. But yeah, that, I think, is it for this episode. In the next one, on episode 9, we're going to go over the template method pattern, what it is, how it's used in the Apex Common Library, its benefits, all that kind of stuff. It's a pattern that I think plenty of people are familiar with, but they just don't know the name of it and, what it is. So we'll go over all that. Hopefully this has been helpful and has explained a lot of things. Yeah, that is it, though. I will see you guys next time. Thanks for watching.